Okay, in this video we're going to do another problem where we're finding roots, and the complex number will be in trig form. All right, find the fourth roots of z, which equals 25 times the cosine of pi plus I times the sine of pi. All right, when we're doing fourth roots, we know that there will be 4 of them. For this problem, r is 25, theta is pi, and since there are 4 fourth roots, n will be 4. And we will use this formula right here. All right. Okay, since n is 4, k is going to take on these 4 values, 0, 1, 2, and 3. So that's how we'll get the 4 different roots. Okay, here is what you would have if you substitute in 0 for k. You'll have root 0 plus 1. In other words, you'll have the first root. It'll be the fourth root of 25 times the cosine. So I'm putting in pi for theta plus 2 pi times 0 in this case. And then that's divided by 4. So we're going to have an angle of pi over 4 for the first root. When I do k equals 1, then I'll be finding the root 1 plus 1 or the second root. I'll be adding pi plus 2 pi over 1. So I'm going to end up with 3 pi in the numerator. So the second root is going to be the fourth root of 25 times the cosine of 3 pi over 4 plus I sine of 3 pi over 4. Okay, and then it goes on kind of similarly. Here's what you get if you put in 2 for k. It'll be the third root. It's changing the angle. It's not changing the modulus. So in this case, you'll end up with 5 pi over 4 for the angle. And then when you do k equals 3, you'll end up with 7 pi over 4. So if you're going to leave this in trig form, there's just a little bit of simplifying to do. The fourth root of 25, if you do that on your calculator, you just get a bunch of decimals. But 25 is 5 squared. And that raised to the 1/4 power simplifies. 2 times a fourth is 2/4, which is equivalent to 1/2. So actually, the fourth root of 25 is the square root of 5. So if we write out all 4 roots in their trig form, they will all have a modulus of the square root of 5. All right. Each one has a different argument. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. You should definitely see some patterns. All right? The modulus is the same for all, but the angles are all equally spaced apart. They're all 2 pi over 4 apart, or pi over 2. When you do a graphical representation of all the roots, in this case I did all the roots of the original number was the same thing as negative 25. You'll see that they all lie on a circle. It's because they all have the same modulus. They were all the square root of 5 from the origin, every single one. All right. And this one had the angle pi over 4, 3 pi over 4, etc. But you can see how they're equally spaced apart. So all the roots will lie on a circle and they will be equally spaced apart. That is true for any kind of root of complex numbers.